On the 13th of November 2002, the single-hull tanker Prestige commenced having difficulties in a storm 21 miles off the northwest coast of Spain and began to spill its cargo of 77,000 tons of fuel oil. The tanker was taken under tow by a salvage vessel and all its crew rescued. On the 19th of November 2002, at a distance of about 240 kilometers from Galicia, the Prestige sank, splitting into two halves 1.9 nautical miles apart. The bow came to rest in 3,830 meters of water, while the stern came to rest in 3,565 meters. In order to avoid any possible further pollution, an ambitious project was initiated by the Spanish government with the aim of extracting the remaining cargo from the Prestige tanks. The main technical challenges that this project faced were the extreme water depth that was well beyond the state-of-the-art for work-class ROVs, as well as all the required equipment, and the viscosity of 5 million centistokes that presented a major challenge for the transfer of the oil from the wreck to the surface. The basic component for all the operations was the Innovator, a 150 horsepower ROV developed by Sonsub. Prior to this project, the Innovator had a proven track record on deep water projects up to 3,000 meters. The Prestige project presented a groundbreaking challenge which involved a modification program to upgrade all aspects of the vehicle to operate continuously in 4,000 meters. This was achieved using the existing 3,000-meter umbilical and the 1,200-meter tether already developed for touchdown monitoring of pipelines. The configuration was changed in that the tether was deployed vertically rather than horizontally. The main items of equipment that had to be modified to achieve the 4,000-meter water depth target were the buoyancy elements, the manipulators, and the camera and lights. The Polar Prince, a multi-purpose DP2 class vessel, was adopted for the operations. This vessel was able to deploy up to 3 Innovator ROVs to full depth simultaneously. The FSO Odin, a multi-purpose tanker vessel with dynamic positioning capabilities, was the designated oil recovery vessel. In addition, 4 tugs were employed for the towing and handling of the shuttles and for anti-pollution control. The positive testing of the ROVs was carried out as the first activity of the 2003 campaign and was essential to the feasibility of performing any of the operations on the wreck. Following these tests, the operations commenced for the survey of the wreck and for the plugging of the leaks still present from the various tanks using a number of different methods and tools. An innovative oil measurement analysis was performed utilizing suitably adapted downhole logging equipment, the result of which indicated that the remaining fuel oil could be estimated at 13,000 tons in the bow, located in port and starboard tanks, while the central tanks were effectively empty. During the flow of oil from the cargo tanks to the shuttles, it was necessary to ensure the free entry of water into the lower part of the tanks to replace the escaping oil. For this purpose, a dedicated water injection system was developed, consisting of water injection casings being installed via the prestige deck hatches. A deck structural ultrasonic beam detection and plate thickness system was used to map the location where the extraction valves were to be installed. Hot tapping and extraction valve installations were performed on each of the 4 cargo tanks within the wreck bow section. The tool which carries the extraction valve is provided with 6 anchor bolt units to lock the valve to the deck before starting the trepanning operations. The center of the tool carries the trepan tool for cutting 700mm holes. The system is operated by ROV through a dedicated IHPU. The shuttles were composed of a main aluminium body with an overall length of approximately 23 meters and a diameter of approximately 5 meters, suitable to take up to a maximum of 350 cubic meters of oil. Following completion of extraction valve installation, the shuttle tanks were towed offshore and prepared for installation. Suitable buoyancy was installed externally to allow controlled transportation through the water column by using the dedicated shuttle handling equipment. The shuttles were deployed to the Prestige wreck in approximately 4 hours, then connected to the extraction valve assembly with the secondary connection to a safety anchor dead weight. The shuttle bottom was provided with an ROV operable door to allow the flow of oil from the oil extraction valve into the shuttle. Once deployed and connected to the pre-installed extraction valves, the final positioning of the shuttle was achieved via ROV. During the extraction process, the oil flow is controlled by ROV operation of the double gate extraction valve, with fail-safe systems to ensure overfilling is avoided. The design of the extraction valves was particularly focused on safe recovery operations, and each valve included fail-safe shutdown systems as necessary to ensure that oil spills were avoided during the extraction process. Each valve includes a double gate system on the top and bottom. The bottom gate is operated by ROV torque tool, while the top one is either operated by ROV or can close automatically through a fuse bolt system broken by the force exerted when the shuttle tank is completely filled with oil. When the shuttle is at a depth of approximately 60 meters, a riser assembly is lowered from the Odin and connected to the shuttle. A major challenge was the fuel discharging operation, given the very high oil viscosity. The adopted innovative core flow solution proved highly successful. Water is pumped into the riser during the discharging in such a fashion as to form an outer sheath around the oil, giving birth to a so-called core flow, where the oil flows inside the water film. This latter functions as a lubricant. It reduces the friction losses between the highly viscous oil and the riser walls. With this method, by using a viscous oil pump mounted at the bottom end of the riser, it is possible to pump the oil up to the Odin tank. The riser and pump assembly system was made up of a number of different components. The main ones being the handling winch, the 6-inch flexible hose which acted as the riser termination unit provided with a pump and a mechanical interface to allow the docking onto the shuttle top interface, and the service hydraulic bundle to allow operation of the riser termination unit from the surface. The recovery of the fuel from the Prestige wreck, although considered by salvage experts as impossible at such a depth, was completed within schedule, within budget, without any environmental pollution, and without any accidents. It has illustrated that the recovery of oil from sunken wrecks is feasible, even at abyssal depths, is safe with zero spillage and no accidents, is effective with over 90% of the oil in place recovered, and has no environmental impact.